Alright, now we come to question 8 in section B for SengKang 2021 prelim. So we have quite a few tables here. I'll leave you to read these tables. Okay, A1 say with reference to table 8.1, predict the observation for reaction of bromine with hydrogen gas. So if we look at table 8.1, okay, so they are trying to ask us to predict here, right? Basically, there is a trend. This is explosive even in the dark, minus 200, low temperature in the dark, reacts explosively. And then we have chlorine, reacts explosively, but with sunlight, takes place slowly in the dark. So the next one, if we see, right, it reacts very slowly in sunlight. So probably in sunlight, it can react moderately, I would say. But in the dark, the previous one was slowly, and then this one is slow even on heating with catalyst. Okay, so in the dark, maybe it doesn't react at all for bromine. Okay, so we can say that it reacts slowly in sunlight and totally does not react in the dark. Okay, as long as you are going according to the trend, I think it is still okay. Suggest the function of platinum is definitely added as a catalyst. Okay, describe the relationship between bond length and bond energy of hydrogen halide. Bond length and bond energy. So if you can see, the bond length is going up, bond energy is coming down. They are inversely related. All right, so you can just quote these two different inverse relationship. I think you will get the 2 marks. Okay, part C, with reference to table 8.2, determine the strongest acid. Explain your reasoning. 8.2. Okay, so acid dissociation, we need to read a little bit. The larger the Ka value, the more dissociation in solution, and thus the stronger the acid. So we're just looking for the largest value here, which is Hi. Okay, this will be the strongest acid. Okay, describe and explain the relationship between bond energy of the hydrogen halide in graph 2 and the strength of acid in table 8.2. So as bond energy increases, right, the strength of acid decreases. So if you look at the bond energy is going down, right? From this table here, bond energy is going down. Whereas if you look at the strength of the acid, it is increasing. Okay, going down the group, it is increasing acidity. Okay, increasing acid strength. Okay, so as the bond energy increases, the strength of the acid decreases, and vice versa. Okay, so as bond energy decreases, the strength of the acid increases. Okay, so you got to explain, describe, and explain. Okay, so the second part, you are explaining more energy needed to break the bonds between the atoms. So between H and X, you want to break this bond, right? So if the bond energy is very strong, it's not easy to break this bond and to get a proton H plus out from the compound. Okay, so that is the relationship. With reference to graph 2, determine the bond energy. So if you look at graph 2, right, bond energy is right here. Right, so you can just quote it from the graph directly. The equation for formation of HBr is shown given that bond energy is 193 for BR, HH is 432, calculate enthalpy change. So we're going to plug out these values, right? So what bonds are we breaking? We are breaking HH bond, we are breaking BR bond, and then we are forming two of the HBr bonds. Okay, bond forming is exothermic, I remember. Exo, bond breaking is endo. Okay, for these two. Okay, so once you calculate the bond breaking, which is 625, and the bond forming is negative 692, we have a net negative 67 kilojoules overall. Right, so it's still an exothermic reaction. Okay, last but not least, we are going to draw out this energy profile diagram for formation of HBr. Okay, so few things you need to take note. You need to put down the activation energy, reagents, and reactants, beg your pardon, and the products. And of course, your delta H, which you have just calculated. Okay, do take note, right? Your arrows for your delta H should point down. EA should, activation energy should point upwards. Hi parents and students, I'm Mr. Kwa, founder and principal tutor from Mr. Khemistry. I do these videos to help more students understand difficult chem concepts, and hopefully more needy students who are not able to afford tuition, they can benefit from these videos. Please help me click that like button and share it with your friends so that more students can benefit. Thank you and see you in the next video. Bye.